Hi guys, so this video is on comparing and contrasting methods. So right now we've learned 3 ways to solve systems of equations: graphing, substitution, and elimination. And at this point we've told you which one to use when, but now we're going to talk about how do I know which one's the best method and when to use them. Because we don't always want to solve it 3 ways. That would take forever, like our last video took forever. So when we want to graph them, it's when we want a visual display or when both equations are in slope-intercept form already. And remember, slope-intercept form is y equals mx plus b. Okay, so substitution. I want to use substitution when one equation has one variable already isolated. And lastly, elimination. I want to use elimination when the like terms are already lined up. Now, I just want to make it clear that I can solve any system any way and I'll get the same answer no matter what, but sometimes it's easier to solve it a certain way. It's not wrong if you don't solve it that way, but it just makes our lives a little bit easier. Okay? So we're going to practice. And notice how it says, determine which method of solving is the best choice for each of the following. It's not a right or wrong choice because technically any of these could go with any method, but it's just which one is the easiest for us. So if I look at system 1, okay, and I look at the format, and I kind of see that, oh look, the y's are lined up, the x's are lined up, and the numbers are lined up. That means my like terms are already set. So all I would have to do is match my coefficients. So I would use elimination for this. And I would use this method because the like terms are already lined up. Okay? Let's look at number 2. Y equals 3x minus 2. Y equals negative 2x plus 3. Those are already in slope-intercept form. So I would use the graphing method for this one. I would use this method because both equations are in slope-intercept form. Okay? And for number 2, I could also say, well, one equation has a variable isolated, and I can also say substitution. Okay, and that would be because if I said substitution, I would say because the y is already isolated. So I would argue that either one of those answers could work for that one. All right, and lastly, number 3. Okay, if I look here, I'm not quite isolated, but I'm really, really close. All I would have to do is get rid of this 2. Okay? Or I could just get rid of the 3 and have y by itself. So I would use for this one, definitely, substitution. And I would use that because the variable y is almost isolated already. So again, we're just making an argument for which one is the better option. Okay? Why don't you go ahead and try system 1 and write your answer here. Okay, so what did you say? I said substitution. I would use substitution to solve system 1 because the variable x is already isolated. You also could have said the variable y. What did you say? All right, let's give it another shot. Go ahead and try for system number 2 and put that answer right here. All right, what did you say? I said I would use elimination to solve system 2. There was a typo, so just make sure to fix that because the like terms are already lined up. All right, if I look here, I have y's already together, x's already together, and my numbers. So that's already set up for elimination. Okay, please bring this with you to class. We are going to be using this tomorrow. Sorry, if you did this early, we're going to be using this on Thursday. Okay, see ya.